So good morning, everyone, and this is lecture number 2, and we are dealing with moment of inertia. What is moment of inertia? What is moment of inertia? Hmm? What is moment of inertia? No one knows this. What is moment of inertia?
Inertia is a property by virtue of its body resists and changes its translation motion. Rotational motion.
You still have to read it from the book. That is not a good sign. Anyways, moment of inertia is a property of a body by virtue of which it resists any change in its rotational motion. And this moment of inertia depends on the size, shape, density of the body, distribution of mass, and the axis of rotation. So if you change any of these quantities, the moment of inertia would change. We had seen how can we find out the moment of inertia of a system of point masses in the last class. I'll give you one more question based on this so that once we understand it, we can move ahead and solve other questions as well. Let me see if I have a question from previous years based on this point masses. No, I don't have point masses, so we will move ahead and instead of point masses, if we have continuous bodies, how can you find out the moment of inertia of continuous bodies? They are not particles, they are not point masses. So how will you find the moment of inertia of continuous bodies? Moment of inertia of continuous bodies. To find the moment of inertia of continuous bodies, you will have to break that body into small parts of mass dm. Then you need to find the moment of inertia of those masses about your axis, and then you need to integrate or add all of those moment of inertia. You will get the moment of inertia of that body about that given axis. Do we understand this?
Yes, sir.
Now, there are certain bodies whose moment of inertia you must know about their axis. You know a moment of inertia of these bodies. Let me see if I can get you that simple list. So, moment of inertia of simple bodies about their center of masses. The first one that you must know is this. What is this?
Rod.
Moment of inertia of a rod about its center of mass axis. Do you see this axis? This axis is passing through its center of mass, And the answer is ml square by 12. Do you know this? Yes or no?
Yes, sir.
Okay. That is the first thing that you must know. Then, have you noted it down?
Yes, sir.
That is the first moment of inertia that you must know. What about the next one? The next one is the moment of inertia of a ring. Moment of inertia of a ring. Of a ring about an axis which passes through its center. You can see this axis, yes or no?
Yes, sir.
Moment of inertia is mr square, whether the mass is distributed uniformly or it is distributed non-uniformly, because all the mass are at the same distance. So even if it is not distributed uniformly, the answer would be mr square only, whether it is uniform or it is non-uniform. Then the next one is disk. Between a ring and a disk, ring is like this, it is hollow like this. Disk is solid like this. Do you understand this? Disk,
Yes, sir.
compared this CD. So the moment of inertia of a disk about this axis, wrong color, about this axis, which passes through the center of mass is mr square by 2. Do we know this? Yes or no?
Yes, sir.
Okay. Now, we have seen that the center of mass of a ring about its axis is mr square. Now, instead of a ring, if I have a hollow cylinder, this is a hollow cylinder about an axis which passes through the central, we call the axis of the cylinder. The mass of the mass of the cylinder is m. The radius of the cylinder is r, and the height of the cylinder is h. What is the moment of inertia of this one? Hollow cylinder. Hmm? What is the center? Hmm? What is the
M R square H, sir.
mr square is? So you have changed the dimension. It's always mass into distance square, and you have changed the dimension of it. Not good. Not a good idea to change the dimension, because if you change the dimension, it does not remain moment of inertia. You have never seen the moment of inertia for all the cylinders? Never came across this? The moment of inertia of this ring is mr square. This disk is made up of nothing but small rings. Small rings. Small rings. Small rings. And the moment of inertia is the summation of all those small rings. And therefore, the moment of inertia of this body is also same as the ring. The only thing is the total mass of the cylinder comes in place of mass of that small ring. So the moment of inertia remains mr square by mr square. Do we understand this? Same as the moment of inertia of the ring, it is made from the ring. So whatever is the moment of inertia of the ring, that same becomes the moment of inertia of this body. Now we come to this one. Moment of inertia of a solid cylinder. Now the cylinder is solid. About this axis, mass of the ring is m, radius of the ring is r, height of the cylinder is h. What is the moment of inertia of this solid cylinder? What will be the moment of inertia of this solid cylinder? No idea? Just say if you have no idea, tell me no idea. So I'll tell you the answer. No idea? This cylinder is made from disc. Whatever is the moment of inertia of the disc is the moment of inertia of the cylinder. So the answer is mr square by 2.
Yes, sir.
So the answer is mr square by 2. From this, we can understand a very small thing and call it as theorem. Theorem of repetition of mass. If you make a body by repetition of same mass, the mass does not change. The distance of the mass from the axis does not change. Then whatever be the moment of inertia of the body, of the mass, the same will be the moment of inertia of the body. You can call that as repetition theorem.
Yes, sir.
You can call that as the repetition theorem. Whatever be the moment of inertia of that small body, the same will be the moment of inertia of the bigger body that you are creating out of that small body. You can call that theorem of repetition. Do you understand this theorem of repetition? If I want to find out the moment of inertia of a body, I will find it out by dm into r square. If this r is same for all the bodies, if r is same for all the bodies, this r will come out because this is constant. It is integration of dm. Once you integrate dm, you will get total mass of the body. That means the moment of inertia of that bigger body will be same as moment of inertia of that smaller body that you had found out. Do we understand this?
Yes, sir.
This is a half ring of mass m and radius r. Mass of the ring is m, radius is r. What will be the moment of inertia of this about this axis which passes through the center and goes like this? It will be same as mr square. If you repeat this twice, you will get the moment of inertia of the ring.
Yes.
This will be same as the moment of inertia of a ring. What will be the moment of inertia of quarter of a ring? The mass is m, radius is r. What will be the moment of inertia of this one? Moment of inertia of this one would also be equal to mr square.
Yes, sir.
What, sir? If you have any arc of the circle, mass of the arc of the circle is m. About the central axis, the moment of inertia is going to be mr square. Do you understand this, or this has gone above our head saying bye bye?
I understand, sir.
From your faces, it looks like everything is going above your heads.
Sir.
Is that so?
No, sir. We are understanding.
Okay.
Done, sir.
This is a sector of a disk. Mass of the disk is m. The mass of this sector is m. The radius of this sector is r. This is a part of a disk, sector of a disk. What will be the moment of inertia about this axis passing through the center?
mr square by 2.
mr square by 2. Okay.
Yes, sir.
Okay. Looking for a diagram. Not getting it. So I'll have to make it. This is a rectangle, or I should say a rectangular plate. So it is solid. The breadth of this plate is A. The length of this plate is B. The mass of this plate is M. Then you have this axis 1, which passes through the center. The question is, what will be the moment of inertia of this, about this axis which cuts it like this? About the axis 1, what will be the moment of inertia of this plate? Hmm. Any idea? No idea. Good idea.
MA square by 4, sir.
M?
A square by 4.
4? How did 4 come? How did 4 come? How did you get 4?
Sir, A is the breadth, no, sir.
Yes.
Then the radius of the edges from the axis is A by 2. So,
Okay.
A square by 8, sir.
Okay. What was the moment of inertia of the rod? About the axis it passes through the center.
ML square by 12, sir.
Here did not. Here also L square by 8 should come, na? No? Radius is R, L by 2. Did I ever say that this is the radius? Did I ever say that this is the radius? You can find the radius of a rod. And if this is a rod, L by 2 is the radius of the rod. No, my dear friends, if you have to find the radius of the rod, it is this. This is not the radius of the rod. Who told you that this is the radius of the rod? Have you ever heard of a term, radius of a rod is L by 2? Have you ever heard of the term radius of the rod? No, I don't think you would have heard about this term. Anyway, the point I was making here is this sheet is actually made up of rods. And you can break this up into rods like this. Break this up into rods like this. So whatever is the moment of inertia of this red rod, that will be the moment of inertia of the entire sheet. And what is the moment of inertia of this red rod? It is m into length of this rod by 12. So the moment of inertia of the entire sheet will be m a square by 12. That is the answer that we were looking at. The sheet can be made from rods. Whatever is the moment of inertia of that rod about that axis, same is the moment of inertia of the sheet about the axis. Anyways, let's try this one. Then I have this as the second axis. This is axis number 2. What is the moment of inertia of this rod or this plate about axis number 2?
MB square by 12, sir.
Chalo. God exists. If we pay attention, God does exist. So you can now break this plate into rods like this. Whatever is the moment of inertia of the rod, same will be the moment of inertia of the entire plate. Now this rod has a length B, and therefore the moment of inertia becomes mb square by 12. Do we understand this, or this has gone above or saying bye bye?
We understood, sir.
अभी पता चलेगा. I'll get to know, don't worry. Get to know. कितना पता चला. Okay. Okay, now before going any further, because it's not possible for me to go any further in this without telling you the next steps. So the next step that we are going to do is known as radius of gyration. So write the heading, radius of gyration. What is this radius of gyration? Radius of gyration. Anyone has heard about this term, radius of gyration? I don't think so. Have you heard? Yes or no?
No, sir.
Radius of gyration. Now, what is this radius of gyration? If I tell you the definition, you might be very confused. So instead of telling you the definition, I'll tell you how you find out this radius of gyration. Now, about different axes, a body has different moment of inertias. The body has different moment of inertia about different axes. It also has, we have devised this term, which is known as the radius of gyration. For any axis, if I find the moment of inertia about that axis, that moment of inertia can be written as the total mass m multiplied by radius of gyration squared about that axis. So about any given axis, the radius of gyration can be found out by this formula. You divide the moment of inertia about that axis, you divide it by the total mass of the body, and whatever quantity you get is known as your radius of gyration. For different bodies, for different axes, moment of inertia would be different, and therefore this k radius of gyration would be different for different bodies. Do we understand this?
Yes, sir.
Now, if you go back, have you written that?
Yes, sir.
If you go back, the moment of inertia of this body about the center of mass axis was ml square by 12. It was the rod. What is the radius of gyration? What is the radius of gyration of this rod about an axis which passes through the center?
Under root L square by 12, sir.
So it is L by root 12. Why it has taken so long for you to give me the answer? It is L by root 12. So L square by 12 ka root. You just cancel M. What is the radius of gyration of this body? Ring about central axis.
R, sir.
R. What is the radius of gyration of this hollow cylinder about the central axis? Eh?
It is also R, sir.
So now we will write all these radius of gyration. What is the radius of gyration of this disc?
R by root 2.
Solid cylinder.
It is also R by root 2, sir.
This ring portion. What is the radius of gyration for this?
R, sir.
For this?
R.
For this?
R.
For this sector of the disc?
R by root 2, sir.
For this K1 about the axis 1?
A by root 12, sir.
For this axis it is different. What is K about this axis? K2?
B by root 12, sir.
So this was radius of gyration. This is the best way to remember this. If I tell you the definition, it will just confuse you. So we don't have to go through that definition. What all factors does the radius of gyration depend on?
Density of the body, axis of rotation.
So whatever factors this moment of inertia depends on, it depends on the moment of inertia. Radius of gyration of a body depends on the moment of inertia, depends on the distribution of mass. So radius of gyration will depend on the same quantity. Do we understand this, or this is gone above our head saying bye bye?
We understood, sir.
You can note them down if you want to. On what all factors radius of gyration depends on? It depends on number 1, size and shape. Number 2, position and configuration of rotation, distribution of mass, axis of rotation, and so on. Whatever moment of inertia depends on, radius of gyration also depends on the same thing. It does not depend on the mass of the body. As you can see, mass does not come anywhere. The dimension is L1, unit is meter because it is radius, which is length. Do we understand it, or this is gone above it saying bye bye? Bye bye, I'm going, don't worry about me. Huh?
We understood, sir.
So please note this down. Noted it down?
Yes, sir.
Then we move on to the next step, and the next step is understanding the two theorems for moment of inertia. Theorem number one is known as the theorem of parallel axis. What does this theorem state? Huh? What does this theorem state? Anyone, any idea? So you may have body of any shape. It can be a 2D body, it can be a 3D body, it can be a body of any shape. Body of any shape will have its center of mass or center of gravity. What do you see here is the center of mass. Do you understand this? This is the center of mass of the body, COM. Now, there are infinite axes that you can pass. There are infinite lines or infinite axes that you can pass through the center of mass. This is one of those axes which passes through the center of mass. Then we have one more axis which does not pass through the center of mass, but this axis is parallel to this axis. Do we understand this? Therefore, the term parallel axis theorem. So what does this theorem of parallel axis say? The theorem of this parallel axis says that the moment of inertia about this parallel axis will be equal to the moment of inertia about the center of mass plus m into a square. What is m? What is a?
M is the mass of the body, A is the distance between the
Two axes which are parallel. So this is what the parallel axis theorem states. The moment of inertia of any body of any size, any shape about an axis which is parallel to the axis passing through the center of mass, the moment of inertia will be moment of inertia about the center of mass plus m into a square. What are the important points that you must remember? This is applicable to all bodies of any size or shape. Moment of inertia about the center of mass axis is minimum, because about any other axis it is this plus something. Do we understand this?
yes, sir.
The two axes must be parallel. If they are not parallel, then this theorem cannot be applied. It can only be applied about an axis which is parallel to the axis passing through the center of mass. So you must know the moment of inertia about this parallel axis through the center of mass, and then you can find the moment of inertia about any other axis. Do we understand this, or this has gone above our head saying bye bye?
We understood, sir.
How we can apply this? For example, if I have a rod, the mass of the rod is m and length is L, and we know the moment of inertia of this rod about the center of mass axis. How much is that? This axis, center of mass axis. How much is the moment of inertia?
L square by 12, sir.
ml square by 12. ml square by 12. Now if I make this blue axis, you can see it is parallel to this. What will be the moment of inertia about this blue axis? What will be the moment of inertia about this blue axis?
ml square by 3, sir.
How did you get it?
From parallel axis theory.
So it is ml square by 12, which is the moment of inertia about the center of mass axis, plus m into distance ka square. Distance between the two is L by 2. L by 2 ka square. You can add these two terms and you will end up with your answer. And the answer would be ml square by 3. Do we understand this?
Yes, sir.
Okay. Now let us say we have this ring of mass m and radius r. We know the moment of inertia about this axis. Yes or no?
Yes.
What is this?
mr square, sir.
mr square. Now we can find the moment of inertia about any axis which is tangent and parallel to this. I have drawn one of those axes. Remember, ring is like this. It could be this axis, it could be this axis, it could be this axis, it could be any axis. Do we understand this? Are you getting what I'm saying?
Yes, sir.
What, sir? This looks like a ring.
2mr square, sir.
So it could be this axis, it could be this axis, it could be anywhere. Tangent axis. Anywhere. Yes, what is the answer? Huh?
2mr square.
Moment of inertia about this axis will be mr square. Moment of inertia about the center of mass plus again one more mr square. So the answer becomes 2mr square. Do we understand this or gone above our heads? Huh?
Understood, sir.
Then this. This is now a disk. Disk of mass m, radius r. Mass is m, radius is r. What will be the moment of inertia about this axis? Yes, bacha.
mr square by 2, sir.
So how will you find it out? You will add the moment of inertia about the center of mass, which is mr square by 2. And again add mr square. You will end up with the answer 3 by 2 mr square. Do we understand this?
Yes, sir.
This is known as the theorem of parallel axis. This is the first theorem that we must understand. What is the second theorem that we must understand? The first is known as theorem of parallel axis. So what is the second one known as?
Perpendicular axis to
Theorem of perpendicular axis. Theorem of perpendicular axis. Now remember, previous theorem was applicable for all types of body. This is only applicable for two D bodies, two-dimensional bodies. A surface, a plate, disc is only valid for plate, disc, rings. It is only applicable for 2D bodies. We call them laminas. Call them laminas. What does it state? First, you draw this diagram. Give you 2 minutes to draw this. Draw this.
sir. Hello, sir.
Yes, you have drawn?
What we should draw, sir?
Oh, sorry. Oh, this one. Sorry. It was pause. Okay. Draw this diagram. So what do you see in this diagram? You see this is a 2D body. We call this lamina. Now this 2D body, two-dimensional body, lies in which plane? It lies in this plane, which is the XY plane. Do we understand this? This two-dimensional body lies in the XY plane. So if this is a two-dimensional body, if my hand is taken as a two-dimensional body, it lies in this XY plane. And this Z-axis is perpendicular to this. Do we understand this?
Yes, sir.
That's it, sir. If you understand this, then we have the perpendicular axis theorem. What is this perpendicular axis theorem? Now, remember that parallel axis theorem. In that parallel axis theorem, one of the axes must be passing through the center of mass. Yes or no?
Yes, sir.
Here, these three axes can pass through any points, but they must have a common junction. This may not be the center of mass. So, all these three axes must be perpendicular to each other. So, what are the points? The three axes must be perpendicular to each other. They can pass through any point. It's not necessary that their common point must be the center of mass, that one of the axes must pass through center of mass. That doesn't matter. So now, the perpendicular axis theorem says that the moment of inertia about the perpendicular axis, and when I say perpendicular axis, this axis which is perpendicular to the plane. Do we understand this?
Yes, sir.
Moment of inertia about this perpendicular axis is sum of the moment of inertia about the two axes which lie in the plane of the body. This is known as the theorem of perpendicular axis. Do we understand this?
Yes, sir.
Hmm. Now, remember, it can be only applied for 2D bodies. The three axes must be perpendicular, and these axes can pass through any point. That point can also be the center of mass. It may not be the center of mass. It can also be the center of mass. Now, using this perpendicular axis theorem, we can find the moment of inertia in some cases. For example, this one. This is a disk that you see. This is a disk of mass m and radius r. Yes or no? About this axis which passes through the center and perpendicular, we know the moment of inertia of this disk. Yes or no?
Yes, sir.
What is the moment of inertia about this disk? About this z-axis?
mr square by 2.
mr square by 2. Now the question that is asked and that you must understand, what would be the moment of inertia about any diameter axis? You understand now? This is the disk. This moment of inertia we know mr square by 2. Now we have a diameter. Can you tell me what will be the moment of inertia about any diameter axis? This is one of the diameters.
mr square by 4, sir.
mr square by 4. That is correct. How did you get it?
Sir, ID, I mean, the diameters are in the plane. So if we add that, it is equals to the moment of inertia along z axis.
Right. If you take any diameter, all the diameters are same. So moment of inertia about any diameter would be same. Yes or no?
Yes, sir.
So what we have done here is we have taken two diameters, one along x-axis, if I call this as x, and one along y-axis. Do you understand this? Both the moment of inertia should be same. And if I add this moment of inertia, this is also ID and this is also ID. If I add this ID and ID, which is the moment of inertia about x and y axis, where the disk lies, ID plus ID should be equal to the moment of inertia along the z axis, which is already known as mr square by 2. Therefore, the moment of inertia about the diameter axis becomes mr square by 4. Do you understand this? It has gone above our head saying bye bye. I'm going, don't worry about me.
We understood, sir.
Pakka?
Pakka, sir.
What happens if it is a ring? A ring of mass m, radius r, about this diameter. Is also a diameter.
mr square by 2, sir.
mr square by 2. Everyone understands this? Yes or no? Boys and girls, do we understand this? So you take this diameter or you take this diameter, both will be equal. This plus this should be mr square by mr square. So one of them has to be mr square by 2. Do we understand this?
Yes, sir.
These are all the things that we must remember about these two bodies. Now I will give you the table and we will note down all the possible things in a tabular form, and you can keep this tabular form. I might also send you this sheet, so you can just write it down. I will send you this in the form of a sheet as well, don't worry. Note this down so that my thing is done. Okay, I'll send you in the form of a sheet as well. You can take the printout of that sheet. So the first one, do we understand ring? We understand this axis, yes or no?
Yes, sir.
The value of the moment of inertia is mr square. The value of k is r. You understand k, na? Radius of gyration.
Yes, sir.
One more thing that is going to come after some time is k square by r square ka value. Going to come after some time. K square by r square ka value. So once you know k, once you know r, you know k square by r square. Yes or no?
Yes, sir.
Ring about its diameter. Half mr square. You understand this? The radius of gyration becomes r by 2 and k square by r square becomes half. Yes or no?
Yes, sir.
3 ring. Tangential axis in its own plane. So you understand the axis. Axis is important here.
Yes, sir.
It will come as 3 by 2 mr square. Why will it come as 3 by 2 mr square? We have found out by the diameter is half mr square. Half mr square plus mr square. Do we understand this?
Yes, sir.
So the rest of the things are like this. Then again the ring about a tangential axis perpendicular to the plane. 2 mr square, we have already calculated this. Yes or no?
Yes, sir.
This is about this. I hope you are able to understand this. Yes or no?
Yes, sir.
Next we come on to discs. Are you noting it down or you are just seeing it? You can just see it, not a problem. If you understand this, you don't have to note down. I am also not a big fan of noting down everything. To understand this, that is the purpose. Just showing it to you because I have to show it to you. Disc. We have the first one about the center of mass. It is half mr square, r by root 2, 1 by 2. About its diameter, it becomes half of that. This becomes 1 by 4. About a tangent in its own plane. So it becomes this plus mr square. This plus mr square. Do we understand this?
Yes, sir.
Therefore, we have these things. Then we will have one more on disk. If you want, you can draw them. If you don't want, don't draw them. Just understand them. There's no need of drawing. You can just understand. If you understand, that is more than enough that I need. Then if you have a disk and you have a tangential axis perpendicular, it will be half mr square plus mr square. So you will end up with 3 by 2 mr square. Yes or no?
Yes, sir.
Okay. Now you have this annular disk. Now this annular disk is somewhat controversial because it depends on whose mass is given. Normally the mass which is given is for the annular disk itself. So if that is the case, then these are the answers for annular disk. Disk with hole. Outer radius R2, inner radius R1. So this is how you get this for this annular disk. half of mr1 square plus r2 square. I hope you understand how this would have been achieved. Yes or no?
Yes, sir.
Then about the central diameter, it will be like this. Then about this one, the answer has changed. You see, 5r1 square plus r2 square. You cannot remember everything. I'm just showing it to you. I mean, whenever you get time, you might have a look at this. I will send you the hard copy for this. Okay.
Yes, sir.
So whenever you get time, you may go through them and see how they are there. Okay. Okay. I'm just showing you one quick look of all the geometrical things that we must know. That's my intention, nothing else. Solid cylinder, we have already seen. Yes or no? Annular disk again, when it is about this axis, it becomes one becomes 3, another becomes R2. It's not possible for you to remember so many things, but solid cylinder you can remember. Solid cylinder about tangential axis you can remember. Yes or no?
Yes, sir.
No one is going to ask you these many things. This is just for your information that I am telling you. Then we have this one. I've got the list of almost everything so that anything comes, you should be able to know the solid cylinder about this axis. This axis, it is like this. No one is going to ask you this. About this axis, it is going to be like this. No one is going to ask you this. But then still, I will send you this entire sheet. Okay, so you can have a look at this. The thing that I wanted to share was this solid sphere about the two axes. We have not done this, so you can note this one down at least, because we will be needing solid sphere and hollow sphere. You can note down this solid sphere and hollow sphere at least. This is solid sphere. About any diameter axis, it is 2 by 5 mr square. About any tangential axis, it is 7 by 5 mr square. You have to note this down. You will have to remember this. We have not done this. Then we have spherical shell. When I say spherical shell, it is a hollow sphere. So once you note down the solid sphere, because solid sphere I have not given you the formula, you can note down the spherical shell as well. You noted solid sphere?
Yes, sir. Done, sir.
Then this is a hollow sphere. Note this down as well. It is 2 by 3 mr square. That is the difference between hollow and solid.
Done, sir.
Everyone? Shall we move ahead?
Yes, sir.
Then these are the next things. Moment of inertia of a solid cone, moment of inertia of a triangle about this axis, moment of inertia about a lamina. We have to remember this because they might just ask you a question based on this. So please remember this, especially the triangle one. Okay. Solid cone, it is 3 by 10 mr square. Hollow cone is not given. So remember, if it is a hollow cone, the moment of inertia about the same axis, it will come as mr square by 2. So remember this. Note these things down because for triangle, they might ask you in a JEE advanced exam. They might give you a question on in JEE, and then if you don't know this, you would be caught. Okay. Note this down at least. Once you have noted this down, we can move on to some question and answers. Noted it?
The answer.
Okay. Then this is the first question that comes. A circular disc of radius r is made up of a copper plate of thickness t. Another disc y of radius r is made up of an iron plate of thickness t by 2, t by 4. Find the relation between moment of inertia of ix and iy about this axis. How will you do this? They are made from the same iron plate. I hope you understand this. Yes. These are the type of questions that are coming. As you can see, this is a question from the previous years. So it can very well come in your exam. I'll give you 2 minutes to note this. Remember, the question that are going to come in JEE from rotation, if it's from if it's from moment of inertia, there's a high probability that you can do it and get it correct. If it's from some other thing, might be a difficult question and you might not do it. So I'm only concentrating on the type of question that are more likely to come and you are more likely to do them correctly. Because if they make a difficult question, trust me, no one would be able to even touch it. And if you go about doing it, you might end up in big trouble because that might ruin your entire paper. So moment of inertia is one topic from which if a question comes, there is a 95-98% chance that if that question is there, you would be able to do it. Whether it's a JEE Main ka paper or a JEE Advanced ka paper, you should be able to do a question from moment of inertia part. Yes. Shall I do it?
1 minute.
Okay.
Sir. Hello, sir.
Yes, bacha.
Sir, it is option C.
It is option C. IY is 16 times IX. How did you get it? That is not the correct answer though. You want to try or shall I do it?
Do it, sir.
What did you do? You tell me that. What did you try? What is the moment of inertia of a disk?
MR square by 2.
Why I'm writing M? Moment of inertia of the disk about central axis. MR square by 2. That's it. That is what you have to do it. So what did you do instead of for body X, you have put the radius as R, and for body B or body Y, you have put the radius as 4R, and it has taken you 3 minutes to give me the answer as 16. And that also is wrong. Because 4 ka square is 16. You have taken 4 minutes of your time and given me an answer which I could have given, okay, R 4R 16. I could have given it in 2 seconds. You not applied any common sense here. Have you used this thickness T anywhere?
No, sir.
No, sir. Then answer is wrong, sir.
For second disk, I have kept R as 4 R.
I know that. That's why one is R, one is 4R. Answer is 16. You got the answer 16, and you have taken 5 minutes.
It is coming 64.
2 square. Achha, it's coming 64. Now it has come 64. How?
Some like I have kept R of second disk as R instead of 4R.
Have you used thickness T?
Yes, sir. I have used it, sir.
Okay, then you might be right. But a small slip of tongue and a small slip of pen, and you're instead of getting +4, you are getting -5. So how you are supposed to do this?
Mass equals to density into volume.
Yes, you have to find out the mass. Mass is density into volume. So what is the moment of inertia of X? Mass is density into volume. Its volume is
Pi r square into T.
pi r square into
T
P into rho, density of iron,
into rho
multiplied by r square by 2.
by 2.
So pi
R
t
per
rho by 2 into r to the power 4. You don't have to do anything further because now you know that all these three are constants. Yes or no?
yes, sir.
That means moment of inertia is directly proportional to
R per 4.
r to the power 4. So the radius of the y disk is 4 times. So 4 raised to the power 4.
And thickness also changed.
Okay, okay. Sorry. Thickness has changed, so I can't do it. Sorry. The thickness is not same. So I'll have to. I can't do it by the proportionality because I have to. The thickness has changed. Sorry, mistake on my part. Mistake on my part. So this is the moment of inertia of the x disk. The thickness has changed. Very correct. Now we'll find it for the disk y. Radius is pi. Radius is 4r. 4r square into thickness is t by 4. So I was making the same mistake as you were making. By 4 multiplied by rho into 4r
Whole square.
square by 2.
Yes.
So now I have pi t rho by 8 into 4 raised to the power 4, right?
Yes, sir.
R raised to the power of 4. So the ratio is 4 raised to the power 4, which is 16 into 16 divided by 8. And here it was r raised to the power 4 divided by 2. You just divide the 2 and you will end up with the answer. It is 16 into 16 divided by 4 eventually. So the answer will be 16 into 4 and the answer would be 64ix. Do we understand this or this has gone above what I'm saying? Bye bye. I'm going. Don't
Yeah.
worry about me. Don't make mistakes because these are the only type of questions that are, if they come in a JEE, you can do them with 100% surety. And if you do a mistake like I did or you did, well, +4 -5. Next one in line. 4 thin rods. Thin means they don't have any width. 4 thin rod made of mass m, same length L, form a square as shown in the figure. Moment of inertia of this system about an axis passing through the center. So pass through the center and perpendicular to the plane. I will give you one or two more axes because they can ask. This is a very common question and there is a high probability that you can have a question of this type. So I'll give you one more axis. That would be good enough. Yes. You have 2 minutes to do this, my dear friends. Remember, these are the type of questions. If they come, 100% surety. And that is why we are doing them. Remember, rotation is a huge chapter. We are going to do the entire chapter, but we are going to emphasize on those questions which are more likely to come. And if they come, more likely to be done in the examination hall. I'm not going to concentrate on those questions which, even if you do it here, you will not be able to do it in the exam hall. 2 minutes Yes, my dear friend, any chance? So shall I do it? Huh? Yes.
Sir, it is option A.
It is option A, 4 by 3 ml square. That is correct. How did you get it?
Sir, I have used parallel axis theorem.
How you have used parallel axis theorem? You can understand that if you can find out moment of inertia of any rod, just multiply it by 4 and you get your answer. Yes or no?
Yes, sir.
So let me find moment of inertia of this rod about this axis. To find out moment of inertia of this rod about this axis, I must know the moment of inertia of this rod about this axis. How much is that?
ml square by 12.
So about this axis, it is ml square by 12. And now I have to add m into a square. A is L by 2. Yes or no? This much is L by 2.
Yes, sir.
So m L square by 12. Moment of inertia about the central axis O will be m L square by 12 plus m into L by 2 ka whole square. You don't have to do it because you have already done it for the rod about the end. And you will end up with ml square by 3. Yes or no?
Yes, sir.
You multiply it by 4 and you have your answer, and the answer is 4 by 3 ml square. Do we understand this? Yes or no?
Yes, sir.
Everyone in the class, do we understand this? Huh? Okay, now I change the question. And now I ask you moment of inertia about this axis. An axis which passes through one of the rods. Let me call this axis as axis X. Remember, when a question comes, it could be of any type, any form, any axis. Therefore, the number of questions are infinite. I can just guess what they can ask. You have 1 minute to do it. Yes, my dear friends. Any idea, or shall I do the needful? Huh? Fast. Time is running out fast. Do it. Remember, the objective of this class is always whatever we do, we must be good at that. If a question comes from that thing, we should be able to do it. But at some point in time, you must also work on the speed. Anyone with any answer? Moment of inertia about this axis. Ding 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 ding. Huh? Yes, we have an answer. Yes, what is the answer? Yes. Okay. Since you can't do it, it's my job to do it. About the axis X. Now, about the axis X, what will be the moment of inertia of the rod CD, the green rod? What will be the moment of inertia of this green rod? It is going to be 0. Why it will be 0? Because this rod is a one-dimensional body and this entire rod lies on this line.
Yes, sir.
Therefore, the moment of inertia of this green rod is 0. Do we understand this?
Yes, sir.
Then we have these two pink rods. Rod number AD and rod number BC. As you can see, the moment of inertia for both these rods would be same. Yes or no?
Yes, sir.
What? How much? So what is the total moment of inertia of both the rods together? This one plus this one. How much?
Square by
Huh? No answer.
2 ml square by 3, sir.
2 ml square by 3. Let me move on to the blue rod. The blue rod. What will be the moment of inertia of this blue rod about this axis? Remember, blue rod about this axis.
ml square.
Well done, ml square, because about the center of mass, if I call this axis, dung, 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 the moment of inertia of this rod about this axis is 0. Do we understand this?
Yes, sir.
So you just add ml square. So for this axis about this, it will become ml square. Now you add everything and you get the moment of inertia about the x-axis. What is the moment of inertia about the x-axis? Huh?
5 ml square by 2, sir.
5 ml square by 3, sir, not 2, sir.
Yes, sir.
You understand this, or this has gone above it saying bye bye? I'm going, don't worry about me.
We got it, sir.
Remember, the questions are infinite. Again, everything goes off. And I have this last axis for you, my dear friends. This axis, I might call it the y-axis. Because I give you y-axis along one of the sides, it will be same as x-axis along one of the sides. So now I'm giving you y-axis along the center. Whatever is the moment of inertia about this, it will be same as along this. Do you understand this? Yes or no?
Yes,
Because the figure is symmetrical. So what is the moment of inertia about this y-axis?
5 by 3 ml square.
Take a deep breath and then do it. This was the x-axis. And obviously these two axes, they are not symmetrical. So it cannot be same. So take a deep breath and then do it. Patience, 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 my dear friends. Don't rush. I have very less patience. And the most impatient human being born on this planet Earth or in any other universe. But still I am having patience.
Seven ml.
Yes, my dear friend, shall I?
Sir, we are doing 1 minute, sir.
Okay.
Four ml square by 3, sir.
4 ml square by 3, sir. I don't know, sir. So I will try and solve it by my own. So I have to find the moment of inertia about the y-axis. I make these two rods, the pink pink rod AD and pink rod BC. We understand that moment of inertia of both these rods would be same. Yes or no?
Yes, sir.
Just find the moment of inertia. Just find the moment of inertia of one rod and multiply it by 2. What will be the moment of inertia of these two rods put together?
ml square by 2.
So it will be m into distance square, that is L by 2, L by 2 ka square multiplied by 2. So the answer would be m L by 2 whole square. That is the moment of inertia of one rod multiplied by 2. Yes or no?
Yes, sir.
So it will be ml square by 2. We get this, or this has gone above or saying bye bye?
We got
Bye
it.
bye. Okay. Then you have to find the moment of inertia of this about this and this about this. Will it be same or will it be different?
Same, sir.
Same. Axis is same. So same. And this is the simple thing that we have calculated, ml square by 12. Yes or no?
Yes, sir.
So this will be ml square by 12 but multiplied by 2 because there are two rods. You add up them and you will get the moment of inertia about the y-axis. What is the answer that you are getting? ml square by 2 plus ml square by 6. What is the answer?
Sir, it is 2 by 3 ml square.
2 by 3 ml square. I hope we have understood this. Yes or no?
Yes, sir. Yes, sir.
Next one, sir. Give the answer fast, sir. 3 rings, each of mass m and radius are arranged as shown in the figure. The moment of inertia of the system about y dash is. Any idea? No idea. Get idea. Here's what Chinese answer.
Doing, sir. Seven ml square by 2, sir.
7 m square by 2. Now we are picking our speed. Everyone understands this? Yes or no?
Yes, sir.
This about the diameter we know. Half mr square. This about the tangent we know 3 by 2 mr square and 3 by 2 mr square. Yes or no?
Sir.
You add them up and you end up with your answer. Chalo, fatafat. Since we have gathered some speed, Remember, you might find one of these questions in your examination hall. This one, I've forgotten the number, so I'll again call it question number 1. 3 rods, each of length L and mass M are placed. You don't have to write the question. Look at the question, solve the answer, get it. You have the sheet already with you, right? For rotation. You'll find question of moment of inertia on that. Just do this. 3 rods, each of length L and mass M are placed along X, Y, and Z axis in such a way that one end of each of the rod is at the origin. What is the moment of this system about the Z axis? And the answer is huh?
1 minute, sir. 2 ml square by 3, sir.
2 ml square by 3. There are 3 rods, one along X, one along Y, and one along Z. The rod along Z will have no moment of inertia. The rod along X, ml square by 3. The rod along Y, ml square by 3. And the final answer is 2 ml square by 3. Do we understand this?
Yes.
Next one. 2 identical rods, each of mass M and length L are joined like this. What is the moment of inertia of this system about a bisector? Hui, 45-degree bisector. Hui, hui, hui.
ml square by 12, sir. B.
ml square by 12, sir. B is the right answer, sir. How did you get it, sir? First of all, what you do? You see these 2 pink rods. You can find the moment of inertia about this axis which passes through the center and perpendicular. Yes or no? So about this axis, it will be ml square by 12. About this, it will be ml square by 12 for this one and ml square by 12 for this one. So the total moment of inertia becomes ml square by 6. Do we understand this? Then you can take these 2 axes. As you can see, if you take any of the green axes, the moment of inertia would be same. Yes or no?
Yes, sir.
You know the moment of inertia about the perpendicular axis is ml square by 6. So any of the axis which lies in the plane, it will be half of that. So the answer will be ml square by 12. Do we get this?
Yes, sir.
Everyone got this?
Yes, sir.
Okay. And I'll give you one more question.
Done, sir.
Everyone done?
Yes, sir.
Then this, you have a rod whose moment of inertia about an axis which passes through the end C is I. Now I have an axis which is inclined at an angle of theta, like this. So the rod is like this and your axis is like this. Do you understand this?
Yes, sir.
What is the moment of inertia of this rod about this axis? And you remember this result. I'll give you 1 minute to think about it. Now remember, bacha, here is one thing that I wanted to tell you. You can call it a trick, you can call it using your brain or whatever. Now, sometimes, as I always tell you, solving a problem may not be your solution. Looking at the options might be your solution. Looking at the option might give you a hint of what the answer is going to be. Now, see, obviously, if you know the answer, you already know the answer. But if you don't know the answer, you can actually find out what the answer would be like. Now, see, this angle is coming as theta. And looking at the terms, all the terms are squared. All the terms are squared. Okay. Now, see, you don't know what is the answer of this case. But, and you can do this whenever you get this angle theta while questions. This is a particularly useful trick for angle theta wale questions. When angle theta is given in some question and the options also has angle theta. You don't know what will happen at angle theta, but you definitely know what will happen when theta is 0. Yes or no?
So
When angle theta is 0, what is the moment of inertia?
0.
One option does not fall in this category, right? So this option goes away. Yes or no?
Yes, sir.
Now, if I put angle theta as 0 in all the 3 other options, they are still alive. Yes or no?
Yes, sir.
Now, the next thing is you can put theta as 90. When theta is 90, when the rod becomes like this, what is the moment of inertia?
I.
Only one option will give you I. Only one option gives you I. Yes or no?
Yes, sir. B.
The answer is P. And remember this. When you have an axis like this, the answer is I sine square theta by 2. Because all the distance, instead of distance becoming R, the perpendicular distance becomes R sine theta. And it is squared, so it becomes R sine theta ka square. So ultimately you get R sine theta ka square. That is the answer. And you can see how I applied this. You can call this trick, you can call this smart work. Whenever you get this questions on theta, you can, apply your brain. Theta, I don't know what is going to happen with theta, but let me put theta as 0 and I know the answer. If I know theta is 90, I know the answer, then I can find out from the option which option is matching. And normally they will not give you option where you will get same answer for all the cases. Do you understand this?
So
So the answer in this case is I sine square theta. Okay, so keep these things in mind, and as we go on, I will be discussing such questions where you can, sometimes apply your brain and get the answer quickly, because if you go on solving this question in the examination hall, you are definitely going to waste a lot of time. But here I did it in 10-15 seconds by applying some common sense. Okay, so I'll see you in the next class. We will still continue moment of inertia for maybe half of the class, because if this question comes, this is a sure short question that you should be able to do. So
Yes,
just
sir.
concentrating on those parts which we are supposed to do. So 2 or 3 types of questions are remaining, 1 or 2 types question which has a whole. So we'll do 1 or 2 questions of that type, and we'll do one or more question. Then we are done with this, and then we can move on in the other part of this chapter. So take care. Have a nice day. God bless you all. And I've sent you the sheet. Please work on those sheets. It will have questions. If you can do those questions, you are good enough. Okay. Take care. Bye bye.
Have a nice day.